Hello everybody and welcome back. We're on the 2004 Pascal paper. Thank you for joining me. We're looking at question number 19. Raffaello's, I hope I'm pronouncing that right. Sometimes when you get the AE's together, it can make something other than just A and E by themselves. But I'm going to say Raffaello's tree grows according to the following rule. After a branch has been growing for 2 weeks, it produces a new branch every week, while the original branch continues to grow. The tree has 5 branches after 5 weeks, as shown. How many branches, including the main branch, will the tree have at the end of 8 weeks? Okay. So we can see sort of week 0, nothing's going on. Week 1, we have a branch. By week 2, we still have that branch, but he's starting to move off. Okay. So then we have, by week 3, the main branch kept going, and now this new branch has split off, and we have 2 branches. Well, the main branch has still been around for more than 2 weeks, so it splits off again. So now we have 1, 2, and the secondary branch keeps growing, but he's not big enough to spawn anything new. So we get 3, and now the main branch branches off again. The secondary branch finally gets to grow a new one. And this tertiary, this third branch, just keeps growing, but now he's 2 weeks old. Okay? So, for the experienced contester out there, for people who know these things, have seen these things before, you can pretty quickly tell this is a question about the Fibonacci sequence. Okay? What is the Fibonacci sequence, some of you out there might ask? It's a great sequence, pops up on contests every now and again, and it's a sequence that starts like this. Okay. It starts 1, 1, 2, 3, 5, 8, 13, it goes 21. And the way we get each new term in the sequence is we take the 2 before it, add them together, and that gets you the new one. So 8 plus 13, that gave us 21. If we want the one after, we do 13 plus 21 is 34. So this is something called the Fibonacci sequence. I might in the future, it's a fairly important sequence, so I might in the future just make some videos dedicated just to the Fibonacci sequence, talk about that topic for a little bit. But it pops up, it's not every year you're guaranteed to get a Fibonacci question. It's not even every other year. But they do pop up, and the general sequence method of add the previous 2 and get the new one is something that also pops up, even if it's not exactly the numbers 1, 1, 2, 3, 5, 8, and so on. Okay? How does it relate to this question? Well, let's redraw the picture. Okay? So we had our tree branch starting off, and after week 1, we had 1 branch. After week 2, we still have 1 branch, but now after week 3, the main branch has branched off. We had 2. And then main branch keeps going, this branch keeps growing, but the main branch branches again. What do you know? We've got 3 branches. And now we've got 4 weeks, which is what was shown to us. Wouldn't you know it? Now we've got now we've got 5. Okay? And now this third branch here, he's big enough to start growing buds of his own. So 1, 2, 3, 4, 5, 6, 7, 8. Look at that. It is the Fibonacci sequence. So we can already predict this is going to go 13 and 21. Okay. Sort of what you can do is you can, to see why this is Fibonacci, what we can do is make a list of branches that are 2 weeks old, that are 1 week old, and at least 2 weeks old. Okay. So we start off with a branch just 1 week old. No 2 week old branches. After the next week, we have a branch that's one 2 week old branch and nothing new. But in that third week, this guy buds, but he's still around. And now this one gets added down here. So we get 1 plus 1 is 2 of those. And this guy will give us a new one. So what's happening here? So now after another week, now we've got 1 plus 2, 3 down here, and we have 2 new things split off. And the totals here are 1, 1, 2, 3, 5. And it's going to keep going. What happens is we sort of have the 1 weekers, let's call them the A's, maybe AK, and the second weekers. Now the second weekers, anything over second week will give us a 1 week old branch by branching off. And in the following week, all these 1 weekers will have aged a week, they'll grow, and they'll give us, they'll be added to the list of 2 weekers. Okay? So whereas before, we're going to end up, in fact, getting the Fibonacci sequence. If I just continue this on ever so slightly, AK, BK, and then we'll get BK again, and then AK plus BK. And then up here we'll have AK plus BK. And down here we'll have AK plus 2BK. And if we were to, I don't really have the space, but if we were to add these up, if we were to get the totals, we'd have AK plus BK, AK plus 2BK. And what would be the next term? It would actually be these two added together, which would be 2AK plus 3BK. And that is, in fact, what you would get when you add this column. So it turns out this type of pattern happens a lot. It's where the Fibonacci sequence originally came from. But maybe you don't care about that. Maybe I've been talking now for 2 minutes. You just don't care. We can recognize the pattern this way, even if we don't care where these numbers come from. And we are able to successfully extend and not have to keep drawing the picture by noticing this pattern. Or, they're only asking us for after the end of week 8. We could probably draw the picture if we wanted to. Okay? But however we do it, either we recognize the pattern that's the previous 2 numbers added together gives us the next week, or we just draw the picture out. We can still get 8 weeks. Okay? So I'm running out of space, so I'm just going to start it again. So week 1, 2, 3, 4, 5, 6, 7, 8. And I just want to carefully read this. We start at 1 week, then 2 week, 3 week, 4 week. And we have 5 branches after 5 weeks. So let's go back. 1, 1, 2, 3, 5. So we do have 5 branches at 5 weeks. It was possible we might have needed to shift over a little bit. 3 plus 5, 8. 5 plus 8, 13. 8 plus 13, 21. So 21 branches. And that was one of the answers. I forget which. It was A. Okay. So that's question number 19 there. And we have only one more to go, and that'll be question 20. And then we'll be moving on to the dangerous part C with the 5 harder questions. Although question 20 can sometimes be pretty hard too. We'll take a look at that in the next video. However, I do encourage you, before watching the next video, to try question 20 on your own and really give it a good shot, because that's the best way to learn, is to actually practice these problems. Okay? So I'll see you for question 20 in the next video.